Good morning. Myself, Dr. K. Lalita Ambihai, working as Assistant Professor, Department of Physics, KSR, College of Engineering, Tiruchendur. Today, we are going to see the topic lasers and their principles. So, this topic covers what is laser, then why so important, then why we choose the laser, and it has some special properties. So, we are going to see the special properties and their principles and what is the necessary condition to achieve the laser and few applications. So the term laser is an acronym word. L stands for light, A stands for amplification, S stands for stimulator, E stands for emission, R stands for radiation. So stimulator means induced, amplification means multiplication. So induced emission of radiation, the light will be multiplied. So this is the meaning of laser, light amplification by stimulated emission of radiation. So the laser is a device that emits a collimator pencil-like beam of either visible or invisible electromagnetic radiation. So the visible region has the wavelength range 380 nanometer to 780 nanometer. So the laser is an artificial light source which exhibits so many superior features than the conventional light source. So the laser light emerges as a narrow beam which can travel long distance without much loss of intensity and energy. So the first laser was ruby laser. Then the ruby laser was invented by Dr. T.H. Maiman in the year of 1960. Since the development of demonstrated in many solids, liquids, gases and semiconductors. So the discovery of laser made an enormous impact on scientific and engineering applications, particularly in the fields of communication, metrology, biology and medicine. Why so important? Because laser is everywhere in your life. So we can see laser in many places in our day-to-day life, especially laser scanner, laser pointer, laser printer. So if you are student or worker, definitely wear ID card. The ID card should have laser barcodes. If you go to library, just you take your ID card and show in front of laser scanner. In fraction of seconds, it displays your all details and mark the empty time in computer. So another example, if you go to any department store, the billing section have laser scanner to view quick price for purchasing items. So then laser pointer. So laser pointer. Any technical presentation, definitely the laser pointer will be present. So the same for laser printer and laser xerox. So in our day-to-day life, we can see laser many more places. So we must know about the laser. Why we choose laser? Because it has some special properties. Laser has monochromatic light, but ordinary light has polychromatic. Laser has high directionality, but laser has less directionality. Then laser has coherent and ordinary light has incoherent beam. Okay, we see the special properties one by one in detail. So monochromatic. Monochromatic means single color. If we consider ordinary light, the light travels as waves. So the distance between the two peaks, it means the peaks of wave is called the wavelength. So each color of light has different wavelength. Do you know white color is really single color? It means really white color? No. The mixture of many colors. It means 7 colors. So it has different wavelengths in white color. But we consider laser light. It has only one color. So only it produces a narrow beam of light. So laser is a monochromatic beam. If we consider laser in red color, it has the wavelength range 650 nanometer to 750 nanometer. Then next one of the special properties is high directionality. Honor light beam has highly divergence. It means more spread out. The divergence takes place for 1 meter per 1 meter for ordinary light. But if we consider the laser beam, it has less divergence. It means very less spread out compared to ordinary light source. The divergence takes place 1 millimeter per 1 meter. So the divergence is negligible. Other one of the superior property is coherent. It means highly coherent. The light emitted from a laser consists of wave trains. These wave trains have same frequency, phase and direction. So they are coherent. Laser light has high degree of coherence. The coherence of laser emission results in extremely high intensity and hence more power. So these important properties make the laser light superior to other conventional light sources like flame, sunlight and ordinary bulb like that. Now we are going to discuss about the principles of laser. Now we consider an assembly of atoms in materials which is exposed to light radiation. It means here light considered as photon with energy hv. Here h is Planck constant and v is the velocity of light. Generally in lasers, three different processes occur when the photons interact with the material. They are the absorption of radiation. The second one is spontaneous emission and third one is stimulated emission. Next, we are going to see the process one by one. Absorption of radiation. So it is one of the radiation process. So the absorption of the radiation is the process by which electrons in the ground state absorbs energy from photons to jump into the higher energy level. It means we consider two states. One is ground state and another one is excited state. In rest of atom should be present in ground state. So now we consider atoms in ground state. If we send one photon with the energy E1 and it has hv, h is the Planck constant and v is the velocity. The photon strikes on the ground state atom. Then the ground state atom absorbs the energy hv from the incident photon and jumps to the excited state. Now the absorption of the energy is E2. So this process is known as absorption. So it occurs only when the instant photon energy hv is equal to the energy difference between the excited state and ground state. E2 minus E1. It means E2 minus E1. So each transition of a certain amount of energy is absorbed from the incident light beam. So the higher energy state atoms, it means excited state atoms, don't stay in the higher energy state for a longer time. So only it is the tendency of atoms in excited state to come to the lower energy state. So the atoms quickly return to the ground state from the excited state by emitting a photon of energy hv. So the emission of photons takes place in two ways. They are spontaneous emission and stimulated emission. Spontaneous emission. Spontaneous emission is the process by which atoms in the excited state return to the ground state by emitting of photons. The atoms in the excited state can stay only for a short period. It means without the influence of any external source or agency. So such emission of light radiation which is not triggered by any external influence is called as spontaneous emission. So this spontaneous emission is a random and also uncontrollable process. Stimulated emission. Stimulated emission is the process by which an incoming photon of a specific frequency can interact with an excited atom, causing it to drop to a lower energy level. In stimulated emission, two photons are emitted. It means one is due to the incident photon and another one is due to the energy release of excited electron or atom. Thus, two photons are emitted. This another mechanism is suggested by Einstein. He found that there is an interaction between the atom in excited state and a photon. During this interaction, the photon triggers the excited state atom to make transition to the ground state energy E1. So this transition produces a second photon which is similar to triggering photon with respect to frequency, phase and propagation direction. So such kind of forced emission of photons by an instant photon is called stimulated emission. It is known as the process is induced emission. Finally, we conclude it plays a key factor for working of laser. In this video, we know what is laser and the principles. It means the different processes involved in laser action. In the next video, we will see what is laser action and what is the necessary condition to achieve the laser action. And also we can see the applications. Thank you.